Okay, so hopefully this will be pretty quick, and then your delta math on this will be pretty quick. There is no need to do separate work for this because it will all be done on the delta math. So when you get to delta math, I want to go through and explain what I'm doing. So we're looking at logarithmic and exponential graphs and their features. So when I look at this, the negative with the 2, that negative causes it to be upside down. So that's why we see it's flipped over. That 1/3 is how much it increases by. And then the 2 is my starting point. So you can see how it starts at that -2. So this function, is it logarithmic or exponential? It is exponential. You can tell by the shape of the graph. You can tell by the fact that it has an x in the exponent. You can tell by the fact that there is no log there. This is an exponential function with a horizontal asymptote. So this will never go over that 0 because as I divide and I divide and I divide and I divide, I will never be able to divide all the way down to a 0. Okay. So then if the asymptote is horizontal, that's where a y equals happens because the x changes, the y does not. And it's at y equals 0 because I told you it doesn't go above the 0. And when I talk about that word above again responds to a y-axis. So then the range of this function. So how far down does it go? It goes down to -infinity. How far up does it go? It goes up to 0. Down to -infinity, up to 0. Okay. So then it's blank on its domain of blank. So its domain is from left to right. So it goes all the way to -infinity, and it goes all the way to infinity. I think it's increasing because it's going up and up and up and up and up. So then the end behavior on the left side is x approaches -infinity. And the end behavior on the right side is y approaches 0. So you see that it has a place where it hits an end, it doesn't go past there. That's the y equals 0. The end behavior on the right side, and y goes to -infinity because it goes down and down and down and down because I'm still looking at the left. So then on the right side, x goes to infinity and y goes to 0. Yes. Okay, so it tells me that all of my information is correct, and then you would go to the next problem. Okay. So again, this is an exponential. I'm going to do one more of these. So it's exponential because of that 1/3 to the x. It has a horizontal asymptote. And a horizontal asymptote is always y equals. It's almost always 0, but sometimes it changes. The range of this function goes to 0 to positive infinity. So it's farthest down is 0, farthest up is infinity. And it's got a decreasing domain because as I go to the right, it decreases because that's a fraction. Okay. It goes from negative infinity to positive infinity. The end behavior on the left is x approaches negative infinity, y approaches infinity. So on the left, it goes all the way left to negative infinity. It goes all the way up to infinity. On the right, x approaches infinity as y approaches 0. Submit that answer. It's good. New problem. So they give us another exponential. I'm going to skip it. They give us another exponential. I'm going to do this one because it's got a shift in it. So the function is exponential. I can tell because it has an x in the exponent. It has a horizontal asymptote of y equals, and this one's not 0. And you can tell it's not 0 because it crosses on the 0. And so really the horizontal asymptote is actually up, and it's up 4. Okay, you can tell that on the graph, but you can also tell that up here in the equation where it says a +4 at the end. That's that vertical shift upwards, so it shifts your asymptote. The range of this function is, range is down to up, negative infinity to 4. And it is decreasing as I go from left to right. And it's decreasing because of that negative in the front that flipped it upside down. On its domain is going from negative infinity all the way to positive infinity because it goes all the way left and all the way right. So on the left side, I look at the left part of the range, and it's negative infinity. I look at the left part of the domain, and it's negative infinity. Sorry. I look at the left part of the domain, and it was negative infinity. I look at the right part of the range because that's the stuff that's on the left. As I look at the far left, it goes to negative infinity, but its height is 4. On the right side, I go to infinity. And on the right side, I go to negative infinity. Done so. New problem. Now gives me a log. Perfect. Okay, so we've been working on logs. We've been trying to understand them. So my log is that function. Right now it has a vertical asymptote because on logs I get verticals because it's just a rotation of my exponentials. So instead of being a y equals, this is now an x equals. It's an x equals 0 because I haven't had a horizontal shift at all. The range of the function, this graph goes all the way down to negative infinity. It goes all the way up to infinity. It is increasing as I go from left to right. Its domain goes, the farthest left is 0, the farthest right is infinity. So on the left-hand side, the farthest left it goes is 0. On the left-hand side, the farthest down it goes is negative infinity. On the right-hand side, the farthest to the right it goes is infinity. On the right-hand side, the farthest up it goes is infinity. Submit my answer, yes. So even though that had a shift, it had a shift downwards, it didn't affect my asymptote because my asymptote is a vertical asymptote here. So you're just going to go through and you're going to do 10 problems of these. That's your assignment. There is no written work that you need to turn in. It's just this. And so it's going through and finding some success there.